Okay, excuse me because time has ended and video is cut. Okay, I was talking that we have to divide this problem into three sections. The first section is the section of going 250 kilometers with a speed of 95 kilometers per hour. And then we have the second section, which is the lunch break, where it had a break of 1 hour, of course, without moving. So v2 was equal to 0 and x2 also was 0. And we have then the turning back section, where it covered 250 kilometers with the speed of 55 kilometers per hour. So he needs to know the average speed, and we stated before that the average speed is the total difference in displacement over the total difference in time. So I'll shrink these. Oh, wait a moment. Okay. So we also know that delta x total equals delta x1 plus delta x2 plus delta x3, and also delta t total, let's make it in capital, excuse me for my horrible font, total equals delta t1 plus delta t2 plus delta t3. So we have delta x1, right? And we have delta x2. Actually, it equals to 0. And we have delta x3. Okay, but do we have delta t1? Actually, we don't have it, so we're gonna deduce the value of delta t1. So we know that v equals delta x over delta t. So at the first section case, we have 95 equals 250 over delta t1. So we're gonna get delta t1 equals 250 over 95 equals, I need a calculator, 250 over 95 equals 2.6. So here we're gonna write 2.6 hours. Now let's get t2. We have that delta t2 equals 1 hour from the given, and also we're gonna get delta t3 the same way, equals 250, making just like we made before, 250 over 55 equals 250 over 55 equals 4.5. So equals 4.5. So I'll just shrink this also, so to free up some space. So excuse me, yeah, and by doing this we can get delta t total equals 2.6 plus 1 plus 4.5 equals 415 into 7 equals 8.1 hours. So to get the average speed, V average equals delta x total over delta t total equals uh, um, 250 plus 0 plus also 250 returning back over 8.1, which will be 500 over 8.1 equals 61.7. So the average speed is 61.7 kilometer per hour in this trip. So as we know here that this is the average speed, although it stopped in the middle for a lunch break, but when we talk about the average speed, we are talking about the whole trip. So it gives us the average speed 61.7. Okay. Where were we? Yeah. And now he wants the average velocity, and actually the average velocity will be equals to 0 because it is a round trip, so it returned back to where it started. So the net distance or the displacement, which is the difference between the beginning and the end and the starting point, will equal to 0, and so velocity will be 0. Okay, let's move to this important definition, which is the instantaneous velocity. And the instantaneous velocity of an object is the velocity of this object at one instant. And this was actually confusing because if you want the velocity of something at one instant, so you want to know it when time equals to 0, and when time equals 0, so displacement will be equal to 0 because it will be a still image. You can get the displacement from the difference in displacement and difference over distance and difference in time. So if you have difference in time equals 0, so by default you'll have a difference in displacement equals 0, because you want to know the displacement at this time, and of course it will be a still image. So this was the beginning of making the calculus, and they said, okay, we will not state that time equals 0, but we will state that time approaches 0, meaning that it will be 0.000001. So at this instant we can get a whole number for the delta x, or the difference in displacement, although it will be very small, but it will be a number, so we can divide it with the time, the very small time, and we will get a reasonable number. So this is the meaning of limit t approaches 0 delta x by delta t, and actually this is the differentiation of x by t, which is delta x by dx by dt. And so if we have an equation of indicating the position x with the relation of t, we can just